For any T statistic, there is a generic formula, and you use the same generic formula for any of the 3 T tests that we learned about. So we learned about the 1-sample T-test, the 2-sample independent T-test, and the 2-sample dependent T-test. And the generic formula is T equals the sample statistic minus the number in the null divided by the standard error. I'm not going to go into detail about the standard error in this video because I already showed you how to calculate it in other videos, but I will talk a little bit more about the sample statistic and the number in the null. So for the sample statistic, if you're doing a 1 sample from the other phase, it's just going to be x bar, the mean. And you're only going to have one mean because you only have 1 sample. So that's for 1 sample. All right. For a 2 sample, and dependent, the sample statistic is going to be x bar 1 minus x bar 2. So it's a little bit different than the 1 sample, but not too much. We just have 2 separate sample means from 2 different groups, and we subtract them. And we're not pairing them because the 2 groups are independent of each other. All right, and then for a 2 sample dependent, it's going to look really similar to the 1 sample, but instead of it just being the raw scores, it's going to be different scores. Different scores. So what you do is you have the pairs of numbers that are paired together, right? And you subtract them, and then you have a whole new column for the different scores, and then you get an average. And that's what goes for the sample statistic. So for any T statistic, you're going to have some kind of sample mean or 2 means and the difference between them. But it looks very similar. You just have to know which one to use when. And then the number in the null is going to be different depending on what type of test you're doing. If you're doing a 1 sample, then it's going to be, it could be about any number. Just depends on what you're comparing that sample mean to. So for 1 sample, it varies a lot. But for a 2 sample, either independent or dependent, this is always going to be 0 for a 2 sample. And the reason that is because if you have a difference of 0, if you subtract 2 means and you get 0, that means there's no difference between the 2 means. And that's what the null is. You're trying to see if there's actually a difference. So you're seeing if this number, this difference is different than 0. Because if it's different than 0, then that means there's actually a difference between those 2 sample means. And the same thing for the different scores. So if you have an average difference score of 0, that means, you know, your pre and post test were about this, or the same for everyone, right? Or about the same and averaged out to be 0. So that would mean that there's no difference between the pre and post test. So for a 2 sample, you're trying to see if there's a difference. And if there is no difference, then that would mean there's a 0. And the no difference is the null. Okay? Here's an independent t-test, t-statistic example. So you're conducting an independent t-test. Your research hypothesis is x bar 2 minus x bar 1 is not equal to 0. So you calculate the sample means and find this. So I have this here because it tells you the order to subtract. So we're going to do t equals, and so remember for an independent t-test, it's the subtraction of both of them. So we're going to do 12 minus 13 because that's how your null hypothesis is written. So you want to be consistent. And then this minus 0, because that's the number in the null, divided by the standard error, which is given to you, which is 1. So we're going to have negative 1 divided by 1, which is negative 1. And so that's our t. And that's it. Right here is a dependent T statistic example. So say you're conducting a dependent t-test. The mean of the difference scores, so that new column that you would have made, is 5. And the standard error of the difference scores is 6. What is the T statistic? Round to the second decimal place if needed. So for this one, we have T equals, and our test statistic is the difference score mean, so that's 5. And remember, for 2 samples, the number in the null is always 0. And then you divide by the standard error, which is given to you. And that will give you 0.83. And that's it. Pretty simple.